Corals also
Well, this is a short video that's going to show.
But being fixed to the seabed, they can't move to find a mate.
Reproduction in
Somehow,
corals.
they must synchronize their sexual activity, and they do so using the rising water temperatures of spring and the phases of the moon.
Full moon.
A few days after the full moon, in late spring, when tidal currents are at their weakest, the corals of the Great Barrier Reef are ready to spawn.
There they're spawning.
Some corals are male and release clouds of sperm. Nearby, a female will be releasing eggs.
I don't think they make those noises.
Other species of coral are both male and female. These release packages of eggs already pre-wrapped in sperm.
Thousands and thousands of eggs to be fertilized by sperm.
Bundles of eggs and sperm float to the surface to mix with others from further along the reef. Each kind of coral times its release to a certain hour on a certain night. That maximizes the chances of cross-fertilization. The fertilized eggs drift away from the reef.
All right, you get the idea. Reproduction in corals. Now, let's look at the two last things. I don't know a lot of detail, but one is about zonation. We looked at zonation in intertidal ecosystems. There's also zonation here. And as we saw in the sandy beach, there's both vertical and horizontal zonation. So obviously, as you go from the surface deeper, there's less light, less primary production by the zooxanthella. You've got different types of corals, different conditions for photosynthesis, different conditions for growth, basically. And so you have different types of corals. You also have different levels of wave action as you go deeper and deeper. And so you have different zones with different, especially physical characteristics. You go deeper, less light, and you're out of the waves more. You've got different types of corals. There's also horizontal zonation. So we'll look at both of those. Begin with this vertical zonation. So here, if you look at this diagram, you've got these compact corals where waves are crashing. They've got to be strong, heavy branching corals. They've got to be strong to withstand the physical challenges of living there. As you go deeper, there's more branching corals. There's the foliase corals. There's corals with bigger surface area for photosynthesis. They can't be up in the shallow where there's more light, but it's harder to live there because they'd be broken apart by the waves. There's also horizontal zonation. If you look at a lot of these coral reefs, especially in atolls, there's the outer part that's the most productive. It's got water, it's got nutrients coming in, That is a place to be, and that is where coral grows the most quickly. As you move towards the center of an atoll or closer to an island in a barrier reef, then right behind the reef, there's a bunch of rubble, there's sediment that's deposited. It's not the best place to grow. And then you get into the middle of an atoll, you get farther away from the edge in a lagoon, in a barrier reef, and it's deeper. There's still corals there. It's a very good place to be in terms of photosynthesis and nutrients and light. But it's similar to what we saw with the rocky shore, where there's a lot of biological. There's a lot of competition in this area. So you find this tongue and groove, you find this reef rubble, and in between the edge where the coral growing most quickly and the middle of the lagoon where it gets to be deep, and there's a lot of different things there. So here's another representation of that horizontally as well as vertically, there's zonation in coral ecosystems. There's different places, including Bermuda that I mentioned before. You can take an entire course on coral reef ecology. You can imagine how many different types of interactions there are. There's all kinds of predator-prey relationships, all kinds of competition, all kinds of trophic relationships, a lot of symbiotic relationships. So it's no wonder you could spend a whole semester looking at coral reef ecological interactions. Well, here's a slide that shows some of those things, all these different ecological interactions that take place. There are thousands, very complex ecosystem. So here's a little example of all the different things that are going on there. It's, you don't have to even read this, just you can look at it and say, wow, there's a lot of different circles, ovals, different shapes there. That is a lot of interactions going on there. That's the whole point of that. Now, look, wouldn't you like to be in that boat or be sitting in that hammock or walking out on that dock, sitting in a chair on that beach? There's your boat and there's your little hammock. Here you are flying in someplace in Bora Bora or Tahiti or someplace. There you are in your little canoe, kayak. You're going to jump in the water. Look at that. Here you are diving in, swimming around with the stingrays in your dugout canoe. There you are. Beautiful places. Places where people love to go, want to be. Here we are, sequestered in our houses. So, 3 videos to get through all this coral stuff. Hopefully it's not too long.